Welcome to the Rising Star Academy. We'll start Chapter 1 Trigonometry, Exercise 1.1, question number 4. Let's start. Before starting the question, we need to know about all these things. When we divide a plane into 4 parts, so this part would become the first quadrant, and we will move anti-clockwise, or we will rotate it anti-clockwise or counterclockwise. So we are moving like this. So this is our first quadrant, that would be the second one, that would be the third one, and that would be the fourth one, like this. The first thing is, now the second thing is this: we need to know what is all positive. So for short form is all silver tea cups. We can also memorize add sugar to coffee. Okay, so this is the way of learning. The first quadrant mean all positive. For S, that mean sine positive, for tan positive, and for cos positive. That is in arrange: first quadrant, second, third, and the fourth one. Now, so what is meant by all positive? It means we are considering 3 functions, that is the sine, cosine, and tangent. So in first quadrant, sine values are positive, cosine or cos values are positive, and tan values are positive in the first quadrant. For second quadrant, only sine value is taken as positive, but the cosine value is negative and the tangent value is also negative. For third one, tan is positive. It means the tangent value is positive, but the sine value and the cosine values both would be negative in this. For fourth quadrant, the cosine or the cos value positive, but the sine and the tan values are negative in the fourth quadrant. So this is the way by which we can find the values according to their quadrant. So in question 4, it says that find cos of x plus t and cos of x minus t, but the values given to us sine x and sine t. It tells us about that the x value is in the quadrant number 1. So in quadrant 1, all values are positive, sine and cosine. And t is in the third quadrant. So we can see that in third quadrant, this one, only tan is positive, but sine and cos is negative. So you can see that the sine is taken as negative value over there, minus 12 by 13. So let's start the question. Let me write the identity we have to use. Now we will use this identity for cos x plus t to find this result. But the problem is this: we have sine x value, we have sine t value, that is sine x and sine t, but the cos x and cos t values are missing. So now we have 2 possible approaches to find these values. Either we can use the identity method to find cos x, or the quadrant method, or you can say that the ratio method we can use to find these values. So I would tell you both methods to find the result for cos x and cos t. Okay, so let's start now. Here we use the identity method. So what is identity? Basically, the identity is sine square x plus cos square x is equals to 1. The first step is we will write sine square x plus cos square x is equals to 1. Now In the next step, if I want to find the cos x value, so I would change this or shift this sine square x to the right side, so it is positive. So when it would move to the right, it would become negative. So here I shifted sine square x on the other side, so that would be 1 minus sine square x. The next step, we are going to take the square root on both sides. So here we took square root on both sides to get the final answer. Now we can see that the cos square x, that square of cos would be cancelled out with the square root. So now the next step would be this one. Now you can see that we remove the square root from cos x, but from 1 minus sine square x we can't remove this. Now I would put the value of sine x into this function to find the value of cos x. So now I would put the value. Now here we will write cos x is equals to plus minus square root of 1 minus sine value is 3 over 5 and square on it, because sine square x is equals to sine x whole square. So according to this, I will take this square, so it's plus minus 1 minus 3 square would be 9, 5 square would be 25. I would use the calculator to simplify and get the answer. So here we will write the square root and then 1 minus 9 over 25. The answer would be 4 over 5. So we know that the cos x, that means x is lying in the first quadrant. So we'd only take the positive value. So my final result would be cos of x is equals to plus 4 by 5 due to the first quadrant. So that's why that would be my result. Now we will find the cos of t by the same method. So let's find the value of cos t. Now we will use the value of sine t into the function to find the value of cos t. So here we have cos of t is equals to plus minus 1 minus minus 12 by 13. So I would use the calculator to simplify the answer. So here I would write the square root of 1 minus bracket minus 12 by 13 and then apply the square. So the answer would be 5 by 13. So I would write the answer over there. 1 minus 144 over 169. After solving it, we will get 5 over 13. So the t is lying in the third quadrant. So in third quadrant, we know that only tan would be positive, the cos would become negative, so I would the negative value of the cos due to the third quad. Now I would put these values sine t, cos t, sine x and cos x into the identity to find my final answer. Okay, now I will put the values. So cos x value we have calculated, that is 4 over 5. Cos t value is minus 5 by 13. Sine x value is given to us, that is 3 by 5, and sine t value is minus 12 by 13. We will simplify by multiplying numerator with numerator and denominator with the denominator. So 4 times 5 would be minus 20 over 5 times 13 would become 65 minus, and the outer minus would become 12 positive, sorry. So that would be 12 times 3 would be 36, and 5 times 13 would be 65. Now our LCM would become 65. So minus 20 plus 36, the final answer would be 16 over 65. Now we will apply for the same cos x plus t. Let me write the identity and putting the value in it. Now for the second identity, cos x minus t, I would put the values. So that would be cos of x value, that would be 4 by 5. Cos t value is minus 5 by 13 plus sine x value is 3 by 5 and sine t value is minus 12 by 13. Now multiply, that would become minus 20 over 65 minus 36 over 65. So 65 is the LCM, so minus 20 minus 36, that would become minus 56 over 65. This is our final answer. Now we will check the other method that I told you in the video. I would check, or I would teach you the other method to finding the cos x and cos t. So let's start. Okay, now we will find the cos x value by using the second method, that is the quadrant method. So here we have angle x, so the angle x would be written over there. So we know that this value is our perpendicular and this value is our hypotenuse. So opposite to the angle x, that is always perpendicular, and the perpendicular value is 3. And definitely this height is hypotenuse, so hypotenuse value is 5. Now we want to find cos x. Cos x is base over hypotenuse, but the base value is not given to us. The hypotenuse value is 5, but for the base value b, we will use the Pythagoras theorem for that. And what is Pythagoras theorem? It says that h square is equals to p square plus b square. And if I want to find b square value, so I would subtract p from h. Now I would replace the value to find the result. So the hypotenuse value is 5 and the perpendicular value is 3. Take the square root. So now 25 minus 9. 25 minus 9, that would become 16, and the square root of 16 would become 4. Okay, so now here we have 4. So it's lying in the first quadrant, so cos x value would be taken as positive. Similar way, we need to find the sine value of t in the third quadrant. So for that purpose, we will make a new triangle in the third quadrant. So let's see. Okay, here we have value of sine t, that is 12 over 13 minus sign indication the quadrant. So it is third quadrant. So let's suppose the angle is forming over here, that is our t angle. Now the perpendicular, and this is the hypotenuse. So perpendicular is opposite to the given angle, so that is perpendicular 12 and the hypotenuse is 13. So now we'll use the Pythagoras theorem to find the value of base b. So I'm going to put in the value. So b square is equals to, the hypotenuse value is 13 square, then minus 12 square. So it is 169 and it is 144. So that would become 25. We will take the square root. So b value would be plus minus 5. So we need to find cos of t. So cos of t is base over hypotenuse. So base value is 5, the hypotenuse value is 13, but we know in third quadrant cos is negative, so we will put the negative sign with it. So here is our second method, using the ratios to find the value of sine t and cos t. So we'll put the value in the same way in the identities to find the final answer. Now in part B, we will find the value of sine x and sine t. We know that the given value is cos x for minus 8 by 17 and cos t would be minus 3 by 5, and both are coming in the third quadrant. So due to third quadrant, we know that in third quadrant only tan value would become positive and sine and cos would be taken as negative. So first of all, I would write the angle x in third quadrant after making a triangle. So let me write the value. First of all, we have cos x. So cos x is equals to minus 8 by 17. So that is our basically base over hypotenuse. So our base is 8. This is our perpendicular value and hypotenuse is 17. Again, I would use the Pythagoras theorem to find the value of perpendicular. So here is our formula for value. We need to find p, so h value would be 17 and b value would be 8. So that would be 289 minus 64. That would become 225. So when we take the square root on both sides, so p value would become plus minus 15. Now the perpendicular value is 15, so I would find the value of sine x easily. So let's find sine x is equals to perpendicular over hypotenuse. So we can see that the perpendicular value is 15 and the hypotenuse is 17. So 15 by 17, definitely in third quadrant the sign would be negative, so I would write the negative sign with it. Now we will find the sine of t the next, but we need to change the angle or replace the angle x by t because both x and t are coming in the third quadrant. So let me write. Now here we have our t function. So cos of t, so base over hypotenuse now. So here we have angle t and the value of cos t, that is minus 3 by 5. So now the perpendicular we need to find. So the base value, this is our base value, this is our hypotenuse value. So base is 3 and hypotenuse is 5. So I would put in the formula, so 5 square minus 3 square, that is 25 minus 9, that would be 16. So value of p would become 4. Now I would find the value of sine t. So here we have sine t, that is perpendicular over hypotenuse. So perpendicular value 4 and the hypotenuse value is 5. So definitely sine t is also in third quadrant, it would be taken as negative. Now I would put these values into the main identity that we need to find, that is cos x plus t equals to cos x cos t minus sin x sin t. So let's solve it now. Okay, here I put the values. Now I would simplify. So minus 8 times minus 3, that would become positive 24, and 17 times 5 would become 85. Next is negative 15 times 4 would become 60 over 85. So 85 would be the LCM, 24 minus 60. So the answer will become negative 36 over 85. Now we'll use the second identity to find the second answer. Now we will simplify after putting the value in the second identity. So minus 8 times minus 3 would become 24, 17 times 5 would become 85, then plus 15 fours are 60 over 17 fives are 85. The LCM would become 85, so 24 plus 60, that is 84 over 85. This is our final answer. In part C, we have the value of cos x is equals to minus 1 by 5 and sine t for 3 by 5, and both are lying in the second quadrant. So now this is our perpendicular, this is our base, this is our hypotenuse. So now given to us cos of x, so that is negative 1 over 5. So that is our base and that is our hypotenuse. So base value would be 1, hypotenuse value would be 5. We need to find the perpendicular value to find sine x. So I would use again the Pythagoras theorem to find the value of perpendicular. Now I will put the value. So that is 5 square minus 1 square. 25 minus 1, that would become 24. So p value is plus minus square root of 24. Now we will find sine x. So sine x is equals to perpendicular over hypotenuse. So perpendicular is square root of 24 and the hypotenuse value is 5, and in second quadrant the sine value is positive, so it would be remain positive. Now we will solve for t function. Here we have sine t. So now in this first quadrant t would become over there. This is t. So definitely perpendicular, and this is hypotenuse. So perpendicular value is here, that is 3. Hypotenuse is 5. We need to find the value of base. So now I would use the Pythagoras theorem to find the value of b. Now I will put the values. So the hypotenuse is 5. The perpendicular is 3. So that is 25 minus 9, that is 16. So b square is equals to 16. So value of b is plus minus 4 after taking the square root. Now we need to find cos of t now. So cos of t is the base over hypotenuse. So base value is 4 and the hypotenuse value is 5. So in second quadrant cos is negative. So my final answer will be cos of t is equals to minus 4 over 5. Now I would put these all answers into the function that or identities that we need to find. So let's solve. So I put all the values in the function. Now I would simplify. So that would become 4 over 25 minus 3 times square root of 24 over 25. Square root of 24 we can also simplify like this. 24, that would be 4 times 6. So square root of 4 would become 2 and 6 would be written as it is. So I would replace 24 with 2 times root 6. So 4 over 25 minus 3 times 2 root 6 over 25. So that is 4 over 25 minus 6 times root 6 over 25. So 25 would be the LCM. So 4 minus 6 root 6 would be our final answer in this part. Now I would solve the second identity. Now I put the values into the second identity, so I would simplify. That would become 4 over 25 plus 3 times 2, that would be 6 root 6 over 25. Now 25 would be the LCM, so 4 plus 6, square root of 6 would be written as it is. That is the final answer.